So in this video actually we'll study about dynamic memory allocation. Okay, so let's see what's that. What I'm saying to tell you guys to study is basically dynamic memory allocation. Okay, very important topic. Throughout the course we'll use it a number of times. Many times we'll be using this concept only. Okay, so let's understand what this is basically. Okay, before understanding that, let me actually tell you one thing. Let me just write something. Some program. Let's write a very small program. Hash include. See, today we'll be studying whatever we'll study, and I'm telling you, there were some problems with arrays. Okay, I'll discuss right now only. We would be able to tackle the problems. Okay, let's see, like we'd actually be able to resolve those things. Okay, so we'll see how we'll do this. So before that, let me just try to explain something. A small thing, okay, but still effective. It will give you clearer basics how actually things are working internally. Okay, so let me tell again. Int I, int j equal to 10, and k equal to 10. Okay, like let's say int k1 equal to 10 and k3 equal to 10. Okay, just writing here. Let's see, we have a pointer star p equal to address of k3. Okay, just writing here. Okay, I have written some lines. Okay, I've written some lines. Okay, also I'm writing here int arr as 100. Okay, what am I doing? Okay, whatever I have written this, actually they are gonna be taking some space in the memory, right? So obviously they will take some specific space in the memory. Okay, let's say this I is taking some this space, this j is taking some this space, k this space, k1 this space, k3 this space, and pointer also is gonna take space. This array also, let's say it's taking this specific space, okay, in my memory. Okay, this is basically known as stack memory. Okay, I told you that we need to give this array like this, and we were not actually able to give it like this. Why? Today we'll see how we can do this like this. Okay, but why we were not able to do this because the issue was, hey, I have no idea what the user will give me. If he gives me a very big array, like say if I write here int a 100. Okay, so compile not 100, sorry, int a n. Okay, compiler has no idea what is gonna be the value of n. Okay, so it will assume, okay, it will assume that, okay, maybe this user wants to put 100 values, so it will actually take specific space, okay, and run like as if like only 100 memories can be allocated out here. Okay, 100 elements can be allocated out here. What if at runtime user will be like, okay, enter the value of n, you'll do, and you'll like n will be given as 200. What is the difference now? User gave me 200, I have only 100. Like I don't have 100. Like the program ran with a specific memory that can only allow 100 elements to go inside of it, but my value is stronger now. It is greater than this specific value, which needs to be assigned out there. It will crash. We'll get an error. Okay, first problem. Okay, this problem today we'll see how we can actually do this. Okay, now let's see what was the problem with this line 10 arr 100. Okay, what if user give me value 2? I have a very big array, right, whose indexes are from starting from 0 going till 99, right? But user is saying, hey, I want to use only 2 elements. You want to use index 0 and index 1. Disadvantage, I'm wasting this memory wastage. Not good, right? Second thing, okay, you've created this size saying that, hey, user might give me a value which will lie within 100 only. Okay, at max the size will be 100, but user gave me a value 500, greater than whatever size I need to store out here. There also is an issue because you have this memory size still here, but user wants beyond this also the size. So obviously they also will be getting an error. Okay, they also we are having some problem. So somehow we'll see that, hey, user is gonna give me an value, right? So I'll see that, okay, you create this size of whatever you want to do. Okay, we'll see how we can do this. Not use exactly this line. We'll see, okay, what changes we'll do. Okay, before that, let me show you. So I told you that everything this will be made in my here only, inside my this. So I'm telling you one more thing, that okay, great, these things have been done. You have a size ARR of 100, and actually you're gonna see this is actually ARR of 100, but user gave you value of 500. From where are you gonna bring this 400 space? Okay, so what actually happens here is exactly we have one more space. Okay, so let's say this is the stack, this is the memory where these all things are kept. Okay, I is kept here, j is kept here, k1 is kept here, all these things are being kept here, and AR also is here only. Okay, this another memory, okay, same memory with a name called as heap. Okay, so we'll use this heap memory. Okay, and as we move forward, I'll show you how we will be using heap memory and trying to tackle this specific line. Okay, we'll see it. Before that, let's see how we will be using the memory on our heap. Till now, whatever we are doing, everything is being kept only on this stack only. We are not even using 1% of this heap also. We are not using at all this heap. Okay, so today we'll be seeing how we are going to use the memory of heap. Okay, okay, great. Let's see. So you can use the memory by using new int, this keyword, new int. Okay, you wrote new int, that means you're saying that hey, create a new integer. It's like as soon as you wrote this new, it's gonna say that okay, you want an integer, so it's gonna create a memory on your heap. It is creating a memory on your heap. Okay, great. But you know this memory, but what's the use? How actually you're gonna access it? You need some way to even access it, right? You want to put, like, let's say 10, you want to put 10 here. How will you put 10? You made the memory, I agree to it. How are you gonna put 10? How? You will not be able to put 10. Okay, so for that, actually what happens, as soon as you write this new int, actually what happens is basically an address is returned. What is returned? An address is returned. Okay, I hope your things are making sense here. Okay, so an address is returned. So what came to your mind? Okay, we can use a pointer here. Since an address is returned, let's store it somewhere like p1. Can I do this? Can I do this? Obviously I can do this, right? So it's saying that okay, whatever is this address here, the value of this address is stored in this p1. That means let's say this address is 700, so p1 is containing the address of this memory block. Okay, I hope it's making sense. Okay, let's even use it and see it. Yes, let's even use it and see it. Okay, so let me just comment this part because we don't need this part. Okay, I'm saying that I'm going to create a new pointer p1 who is getting this. Now I can change the value if I want. I can do this, right? If I print the value star p1, I'm gonna get the value as 10. What I've given 10, right? Yes, I'll be getting 10. So effectively what have happened? See here, one more thing. This part, this is getting created on this stack. Okay, so on this stack p was been made. Okay, but on the heap I have made my this new int whose address I have no idea. So using this p star p equal to new int, I'm like okay, this p is being contained on this stack, this is heap. So whatever is the address of this is going to return here. You point to that address. Let's say it's made at 700, so 700 is stored here. Okay, so see, this p is getting created on this in this stack. This is basically this new keyword. After using this new, you are creating the memory in the on your heap. Okay, and basically it has no name. Okay, on the heap you have no name, so we're going to access these things using a pointer only. Obviously you can use it. Now you can even use it, you can put the value, you can even print it out, right? Simple. If you want, you can even increase values like star p plus 1, star p equal to star p plus 1. What does that mean? Hey, star p means go to that specific address. Star p plus 1 means whatever value is kept here, let's we have kept 10, increase the value by 1, make it 11, and put it in star p only, so it will effectively become 11. Till this makes sense? Let's see if you want to see this part also. After printing, I'm like, okay, star p 1 equal to star p plus 1, and let's print this line again. P is, it's not p, is p1, right? P1. Okay, so we will be getting 10 and 11. So 10, and after that 10, I have increased the value and I'm getting this 11. Okay, so similarly now see what's the issue. Now what's the advantage? I can actually write this star p is actually pointing to, what did I write here? Very important thing, very important to note. Okay, I wrote, okay, great, star p c is gonna take only 8 bytes. We know this. It is being made on my stack. I have a heap, very big, bigger than stack at least. Okay, new int n. Now even the user, if it give me a very large value, let's say this value, I am not storing this here. I am not storing here. Okay, or whatever the amount the program is running. I am storing this value I'm gonna store it here. Okay, on the heap. So I'm gonna actually, as soon as I wrote here new int, whatever I'm using, I'm actually gonna store it here. Okay, so let's say this size, for our understanding, let's say the size is 5 only. Okay, and this 5 size is basically made on the heap. Let's say n value is 5. N value is 5. So first thing, no memory wastage. Why no memory wastage? The user is saying, hey, I want a size of 5. I'm like, okay, you want a 5 size 5. So I'm creating the size 5 on my heap. See here, no 100. Like in the previous, we were doing this a100. So there 95 spaces were being wasted. But here, no, they're not wasted. I'm going to take the value from the user itself. And then I'm like, okay, you want this size, you get this size. Now again, this will return me the address. Whose address? We have seen, basically it returns the address of the first index. So it will return me an address. Okay, it will return me an address. I'm going to keep this address in my p, star p. Okay, great. So I've kept the address of star p. So can I access this p of 0? Can I do this? We will be getting here value 10. We have already seen this. Okay, that although it's pointed, but we can actually use it as an array, as if this was an array. Okay, why we can do this? Because internally this line is basically written as star p. Star p means, hey, go to this specific address. What is this address? This, and put the value. So I'm putting the value, is fine, I can do this. If you're going to put here 1, so you want to put here, so you can do this star p plus 1. Effectively, what does this mean? Hey, first of all, go to p. Okay, I went to p. P is basically this specific address, the 0 index address. P plus 1 means, hey, go one more index ahead. Star p means go to that specific content, and like if I'm gonna put, like, let's put 10, so put here also 10. Okay, wanna see? Let's check and see. It'll be better. It'll be better. So let me not erase that part. Let me erase. See here, this star p is basically created here. Okay, this is p and it is having the address. Okay, making sense? Okay, so let's see how we can actually access this. Very important. Okay, this is very important topic. Okay, so the thing I want to say is p of 0 equal to 10, p of 1 equal to 20. See it properly, I can actually access it using as if like this p is basically an array. Okay, as if this is an array. So if I print here cout p of 1, obviously I'll be getting 20 as my answer. Okay, so let me just not print these things. Okay, n was not declared. Okay, we need to even declare n, sorry for that, int n, right? And gonna ask the value from the user. Cout enter n. We're getting a huge power. Okay, now there will be no wastage of energy and no wastage of memory, or like we will not even be in a situation that where I have only 100 space and the user is saying I want 200 space. Okay, it's basically going to be given by the user only. So let's say, let's take this. So let's say user gave me a value 10. Okay, that means a size of 10 is been created, an array of size 10 has been created, and out there p of 0 is 10 and p of 1 is 10, and I'm actually trying to print the value of p of 1. So effectively I'll be getting 20 as my answer. Why 20? Because p of 1. Okay, so if you want to see in more detail, I'll do one thing. I equal to 0, I less than, and I plus plus, see in the value of p of I. Okay, p of I, after putting the value, let's even print it. Control C, Control V. Let me say here C out now. It should be C out now. So it's gonna be C out. Okay, so here I'm gonna actually see I'm creating internally dynamically this in on the heap. This is on the stack. Okay, I'm actually trying to take the value of n. I'm taking the value of n here, right here itself. Okay, I'm taking the value of n here itself. Okay, enter the value n, create the size of memory array, and try to put that specific that much values, and even print those values. Okay, it should be 0, and even here should be equal to 0. And let's not write this, we don't need this, right? P of I, right? So this is mistakes. Now it should be fine. Okay, so it's saying that okay, it's saying that enter the value of n. I'm like, okay, I want to put 10 values. Okay, I'm saying that it be 1 2 3 4 5 6 7 8 9 10. So what should be printed? 1 2 3 4 5 6 7 8 9 10 should be printed. Okay, 1 2 3 4. Actually I did not give space, that's the reason you might be confused. So let's give a space here itself. And now let's take only 5 values. Already you know how to take. So I'm like, okay, give me a size of array of 5. This is 1 2 3 4 5, and just printing the values. What's the advantage of this line? Now this line here, I'm not using any I'm not wasting any extra space. Okay, so I'm saying, hey user, you take the control with you all. Okay, it's fine. You give me a value n, and based on your n, I'm going to create a size of array. So user gave me 5, I'm like, okay, you want 5 value, 5 size array, so do this 0 1 2 3 4, and I'm putting the values out here, and then actually just printing them out. I hope till here it's fine, making sense. Okay, again I'm saying this star p is basically created on this stack. Okay, this is basically created on this heap. Okay, making sense. Although not only this, even this part, let's erase this part at least. Even this thing, where is it? Here, this also has been created on the heap. This is on the heap, this is on the stack. Okay, making sense? I hope it's making sense, right? Okay, so see, one thing has been this till here we have done. Okay, let's keep the till here on in this video. Okay, so in the next video we'll discuss about something, how to delete these things. Okay, these things are basically created on the heap. Okay, so we'll see what is the demerit of it. Okay, and how we can actually handle it. Okay, so let's see those things in the next video. Okay, so see you guys here. Okay, thank you.